First of all, am I audible? Yes. Okay, sure. So let's go ahead and start our presentation. Okay, so today's topic is artificial neural network tutorial, right? So we are going to start with the basics of artificial neural network, and slowly, gradually, we will see how we can build a particular model itself to do the classification of a case where we are going to see some data set, and that is to detect whether the nodes are fake or they are real nodes. So let's start it, and let's fully screen it. Okay, before we do this thing, there is one important thing to tell all of you guys, that there is a particular link which is meetup.com Edureka, right? So if you do this thing like www.meetup.com/Edureka, then you will be reaching on this particular page. And on this particular page, you can see there are lots of webinars here. So here you can see there are upcoming events. And this is currently going webinar, which is I'm taking, and then there would be another at 6:30 around today, and so on. So more webinars are there, and there would be around 150 webinars. So if you want to attend all these webinars completely free of cost, you can just join this group. So if you join this group, you will be able to access all the webinars. So lots of information, knowledge you will get just by attending the webinars free of cost, and you can be aware what is going on in the industries and how the problems are being solved, as well as little bit hands-on also you guys will have. So let's start the session now. Okay, so here we are going to see, first of all, even why neural network comes into the picture, right? Even though we have lots of algorithm existing in data science already, and then especially why neural network we have, and why it is becoming suddenly famous, so much famous, such a way that it becomes itself a new branch of our techniques, right? Then we'll see what are the motivation we have behind neural networks. We will talk about neural networks, and then we will see the easiest neural network that we have, that is which we call as a single layer perceptron. And after that we will switch to little bit more complex neural network, and which we call as multi-layer perceptron. And after that we will see one case study which I already told you guys in starting, that is detecting fake or real nodes, right? And after that we will discuss about some of the applications where neural network is being used nowadays. Okay, so first of all, we will begin by looking at the reasons behind the introduction of neural network. So why neural network even comes in the picture, right? So before neural network was existing, so what was happening? Then it was more like, unless the specific steps that a computer need to follow are known, the computer cannot solve a problem. So what does it mean is, we need to program the computer completely in such a way that I am telling it each and every step what it should do, right? And then it follows all those steps every time a problem need to be solved. And even if there is a little bit twitch in the input which we are giving, then it might suddenly fail. It cannot handle lot of uncertainties which might be coming, right? So it was more like a very rigid system, we can say, right? And then this restricts the problem solving capabilities of conventional computers to problem that we already understand and now know how to solve, right? So it is more like, what we want to say is this, that we human beings solve lots of problems, right? We ourselves is able to recognize the faces of the people around us, and numerous number of people we remember, right? We able to find out the things, do lots of activities like driving car, playing some sports, and all these activities, right? But computer or machine was not able to do it in earlier days, even though we got huge computation power, right? So there was enormous computation power had been available to us, right? But we were unable to utilize those computation power, right? So then as neural networks arises, then what start happening? Then computers start doing the things that we don't exactly know how to do, right? It means there are problems, means I don't know that how I can tell it to the computer. Let's say the face recognition system, right? So I am doing this face recognition system. I see the people around me, and then I recognize, oh, that is this person and that person, right? But if I have to program my computer by simply telling the steps, step one is this, step two is this, and do all those things, computer will not be able to do these things, right? So neural network takes care of those things even where I do not know how to reach to that particular solution, right? And it automatically finds the way to reach those solutions. So how does it do? Let's see this thing, right? So one thing about it is this, that neural network learn by example. Means I give example, right? I do not program it to do some specific task, right? So if I want it to recognize the faces of people, what I will do, I will give it faces, I will give the face, I will give it images in which faces of people are there, and then I will tell which person is in which image, right? So this is a person one in the image one, this is person two in the image two, right? So this way I will be just giving them example, and when I pass, let's say 10 images of person one, 10 images of person two, and so on, then automatically it will start finding out the pattern and learns automatically that okay, this particular person has all these facial features and so on, kind of stuff. Okay, so let's talk about what is the motivation behind neural networks. So that motivations comes from nowhere else but from the human beings only, right? So we human beings have enormous computation power itself in our brain, right? And what is this from where this enormous computation power is coming from? Very small thing, that is neuron we have, right? So all of you know that we have millions of neurons in our brain, and each of these neuron is connected to many other neurons in such a way that it becomes around billions of connections in our brain, right? So the whole thing, or the building block of neural network, is the same neuron which we have in our brain, right? So we are trying to imitate those neuron cells in the real world, in the computer. Actually, we are trying to give them those neurons through the programming. Okay, so what normally ways the things happen actually? So as I told you, the neurons are interconnected to each other. So what here it is happening here, like we have dendrite actually. So first of all, we have, this is a diagram of neuron, right? And you can see this is a cell body actually, and this is the mitochondrion, right? And then here we have a nucleus, this thing, right? So nucleus is very important thing. We will talk about it a little bit as well. So we have the dendrites. So these are the dendrites actually, which are connected to other cells. So I might have some more cells other places, right? And these dendrites are the one which is connected to other cells. So basically other neurons, right? So these neurons communicate with each other by passing some information. They each neurons do some calculation and then they pass the information, right? And another important part is the axon, right? So axon do what? As dendrite do the receiving of information coming from other places, or we can say signals in more better way. Axon do the transformation. Basically it transmit the signals. So one signal is being connected, so some calculation happen into this nucleus, right, after receiving the information from dendrite, and whatever result this particular neuron creates, that would be transmitted to some other neurons which are dependent on this neuron for getting executed. And we do this thing by through the axon, right? So axon get here, and then it's divided into synapses, and these synapses are connected with our with the other neurons dendrite, right? So this way the information is being passed, the calculation is being done at each and every node, and then the information is being passed between them. Okay, so now let's see what are artificial neural networks, right? So let's talk about, as I have taken the example till now for the human beings, right? Like face recognition system, how we are recognizing the faces, right? Similarly, we might want to make our system to learn about the, dogs, right? So it might happen that I train my system, right? So machine to with this image, with this image, with this image, and with this image, right? And then I tell them, okay, this is a dog, this is a dog, and this is a dog, as well as this is a dog, right? And let's say if this is a machine, and if I have a human being also, and I do the same thing, dog, 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 and dog, these four, right? And then to the human, to the machine where I'm not executing the neural network, then if I give it some other image, right? So like here we have another image, right, of the dog, right? So this is here we have another dog, right? And this dog might not be looking like these dogs, right? but human being will be able to tell, okay, this is also a dog. But if we talk about the machine programs, right, which has learned just by looked at these images, right, cannot generate a pattern out of them for the dog, right, will not be able to guess that this is also a dog, right? So without neural network, we will not be able to do as such good classification in this way, right? But if we discuss about with neural network, right? If we discuss about with neural network, if we train our model with neural network and with the same images here as I'm showing here in the earlier cases, then not only it will be able to classify these dogs images, but some other dogs images as well, which might not be looking exactly like them, right? So this is a beauty of neural network. So let's focus on how neural network work. Okay, so let's start with the first, that is a basic neural network, and we call it as a perceptron, right? As we said already initially, that we are going to discuss about the perceptron first, right? So perceptron is basically it is having only one neuron, right? So as we say, the building block of a whole neural system is neuron, right? But each neuron do its calculation, even though whole output in the bigger applications might come by merging the different neurons together, right? But each and small neuron, one each and every neuron has very specific operations, right? And how does it work? So like it can also generate some, some output. It gets some input, it works on them and generates some output, right? It might happen that it might not do the complex application alone, but still it do some part into that. So let's see which kind of applications and all also we can do using it. So let's talk about simple one neuron here. So how does it happen? As in the center here, we have this nucleus, right? And this nucleus is being is receiving actually information from the dendrites, right? So dendrites, the information came. So we can think that these are the inputs, right? So here I'm defining them, the dendrites, right? X1, X2, and so on till Xn. So it might be connected to n number of dendrites, right? And using them, it is receiving the information. Okay, so this is input values we say, right? So when the input values come, then we attach some weight to them, right? Weight basically decide how much important a particular variable is, we can say actually, or it might be saying, the part of the calculation, like this particular thing is going to be negatively help us in doing something or positively, right? So like we have negative, so if we do calculations, we get negative value, positive value, all kind, smaller values, bigger values, right? So how much weight should be given to this particular input, right? In negative ways or in positive ways, or I should give more importance by giving bigger values in whether it is negative way or positive way, or I should give very little importance to this particular input which we are receiving through this neuron by putting by keeping this value very small, right? So each of these neurons has their own weight, right? And after that they basically get we can say it's scaled up with this new weights, right? So each value is coming, it is scaled up with this weight, and then it comes here, right? And then this unit do processing, and processing is very simple here. It is not doing very complex processing, but just an addition of different values, scaled inputs we are getting, right? So I can say x1 w1, it is equivalent, I can say x1 is I have scaled the x1 to some value, right? So all these inputs I am doing summation of them with their scaled weight, right? And then this is an output for it actually, right? So it generates some output here, right? So let's say this is an s. So this is first part of the computation, right? Now I want this s to go through some kind of transfer function, right? A particular kind of value which I want to generate might can be generated using some function, right? If I pass this value to some function, right? Whichever summation we generated, if we pass it to some function, we will discuss about what these functions are, what are the different functions are available, right? And if I pass this value to this function, then it will generate the final output. And this output can be, if we are talking about only one neuron, which is perceptron here in this case, that would be our output of our neural system, right? So here we get y1, y2, y2, y3, and so on till yn, right? As man output we want, right? Okay, so here we have n inputs, but it doesn't mean that we will have n number of output as well. It might be lesser compared to the input values, and even more than the input values, right? But it is rarely happen that it is more than input values. Okay, it might happen anyways. Neural network has the power to deal with the both. Okay, so let's go ahead. Let me just delete. Okay, so let's talk about the modes in perceptron, right? So what are the different modes a perceptron go through, right? Or even our brain go through actually, right? So one mode is training mode, right? So what does training mode represent? That when I am training, right? Like if I want to learn any skills, right, I go through some training, right? Then this is a training mode actually, right? And then once I learn this skill, then I might be doing competition, and then it becomes using mode, right? We are using those skills, right? So in the army, in the defense, first of all, people are being trained, right? And then there what they learn, those strategies, techniques, power is being used in the field, right? So that is where, because neural network initially doesn't know what should be the correct value of these weights, right? How do we know what should be the correct value of these weights, right? So that we can get the desired output, right? We need to make sure that we are able to adjust the weights so that we can generate the desired output. And adjusting these weights is known as the training mode, right? So we need to find the correct weight here, right? That is what we call as a training mode. Okay, so let's go to the activation function now, and let's look at the what are the various types of activation functions available. So one of the important function is staff function. Staff function do whatever value you are getting as an output of summation, right? So like here we were seeing s value, right? And then we are passing it through some function f, right? And this function f is basically our activation function only, right? So we will be passing here s value to it, and with respect to this s value, it will be generating some further output, right? Which we will call as the final output. So this s value would be transferred, right? So that is why we are calling this as a transfer function. So let's see how it is being done. So one of the way to do this conversion is staff function. So staff function do what actually? Staff function says that the output value will be only two, whether it would be my zero value which I want as an output, or I want higher value, let's say one value which I want as an output, right? So here you can see that for some x-axis value, so x-axis is representing our s value only, right? The sum which we have calculated in the last class, right? So this is our x-axis value which we have created here, and for that y-axis is representing our f of s, right? That is an output value coming out of that. So it might happen, so I would be generating this particular staff function, which will do what? If the value is less than this value, right? This value of s, if on the x-axis, if s value is on this side, then it would be output would be 0. But if the s value is on this side, right, then the output would be 1. So these neurons just basically give output in the form of 0 and 1, right? So this is what we call as a staff function. Okay, then there is another important function we have, which is sigmoid function, right? So sigmoid function is for what? So let's from the staff function, let's come to first sign function, right? Rather than having values 0 and 1, I might be interested in knowing the sign of them, right? So -1 and +1. You can think that there are some cases. Let's say there is I want to I want to create a system which can find that whether a person is having a let's say cancer or not, right? So we are saying here one is positive, another is negative, we can say, even though we can say 0 1 as well here, but these two are opposite extremities, we can say, right? So -1 +1, basically whatever output it is generating, I am converting it into two values only. It would be whether the +1 or -1. So how does it happen? That if the sum that is being generated by our neuron, if it is a negative sum, then it will just give us output as a -1, and if it is a positive sum, then it will give us as output as a +1. That is why you can see at the center of the coordinate system, it is after that, as the value of x become positive, which is s value, it is just keeping output as +1, and here in this case it is putting output as -1, right? So whatever sign would be there, that would be coming as an output there. Okay, then we have a sigmoid function. So sigmoid function do what? Sigmoid function is basically for generating values. That's not only two values like 0 1 or -1 +1, but the values which goes from 0 to 1, right? So here you can think that we are able to generate infinitely values in between of 0 to 1. And if you want that, your question might be that is it the whole thing we have? Then one thing is that you can just scale it up into whichever limit you want your output to be actually. But 0 to 1 we are going to see in lots of places that we want output in terms of 0 to 1, which is basically, this is most of the cases, these are the intermediate results. So you see what do we mean by intermediate results, and these are basically mostly in terms of 0 to 1, right? So if I am interested only the output which is going from 0 to 1, then I will use sigmoid function, and it is of shape S actually, we can see here, right? And at infinite x-axis it touches 0, and the top infinite on positive x-axis it touches 1. Okay, so let's go to the next slide. So let's see our perceptron training, right? So we said that there are two modes. One is training mode and another is our use mode. So one question might be, how do we train the models, right? How are we training the weights of my model? So let's understand with an analogy. So we are going to see this particular case, and the case is that suppose you want to go to beer festival that is happening near to your house, right? So there is a beer festival near to your house, and your decision will depend on multiple factors, right? So now you have to take decision whether you want to go for this beer festival or not. So it will depend on many factors. Number one, how is the weather, right? Outside, whether the weather is good or it is bad. And second is also your wife is going with you or not. Let's say the time during which beer festival is happening, your wife is also accompanying you, and then you have to think whether you want to go in that case or not there. And any public transport is available, right? So like different people might be staying at different places also, and then so they want to see whether that public transport is available there or not, and accordingly people decide whether they should go for this festival or not, right? So let's see, like here we have the weather. How is the weather, right? So even though we can talk about temperature like 25, 30, 15 degrees Celsius, different values, rain and all those stuff, right? But in reality, from our point of view, we just want to see only two values for a weather, whether it is a good weather or is it a bad weather, right? And so it becomes one. I say x1 variable value is 1 if weather is good, and its value is 0 if it is a bad weather. Similarly, another thing is like your wife is going with you or not, right? So if she is going with you, then we will say, okay, this variable takes the value 1, right? So you can see here, we start putting x1, x2, x3 here. So I hope you remember that perceptron, we were passing the input, and these x1, x2, x3 are the ones which are our input variables only, right? And for x2, whether its value would be whether 1 or 0, right? If its value is coming as 1, it means your wife is going, and if not, if it is 0, it means your wife is not going with you. And similarly here we have another case, which is any public transport is available or not, right? If public transport is available, we will set this value 1, otherwise we will set this value 0, right? So these are different input variables we have, right? And what do we want as an output? That finally you will go to the beer festival or you will stay at the home, right? So we can say the output value of our neural network would be 1 if we go to the festival, right? And its value would be 0 if we do not go to the festival, right? And we will stay at home, it means, right? So let's see how the things are going to happen. Okay, now one thing that you guys might be doing, you might think that you want to give different weightage to the different factors, right? All the factors might not be equally equally important for you, right? Some of the factors are very important, and while some of them is not, right? So suppose, let's say the weather is very important factor for you, and let's say if it is not go, then it is pretty much decided that you will not go for the beer festival, right? And you will stay at home, right? And still it doesn't matter in this case. It might happen if a weather is not good or it is bad, then you might just decide better I will stay at home irrespective of what are the values of other two variables, right? We saw what are the other two variables as well, right? So like here we saw one is like wife is going with you and public transport is available or not, right? Once whether is it is decided and whether is bad, I might decide to stay at the home. Okay, now let's see how to assign weights, right? So let's assign weights to our three inputs. So we got three inputs, x1, x2, x3. So to each one of them, we are assigning these weight w1, w2, w3, right? And let's say initially we are taking some values for weight, let's say 6 to 2, and we are setting some kind of threshold as well, let's say 5, right? So what does it means, threshold 5? It means you can think that this particular neuron will fire, right, or send the positive values, you can think, or a particular kind of value, it would be fired if it crosses the threshold, right? So we can think that lot of great a lot of great things are happening around us, right? But not all great things are able to make us so much happy, right? Even though it should happen, right? It might happen that it's not happening, right? But whenever something great things which in our neuron network is able to cross some threshold, right, then we become happy, right? So a particular happiness neurons get fired, right? So same thing here in this neuron system we have, that is, and you might be seeing also in reality, sometimes you see a person and then you say, oh, he or she looks little bit like that particular person, right? It means is your neuron has not been fired completely for the particular face you remember, right? You are saying little bit that person look, right? Because it is reaching there but not able to cross that particular threshold, which in your mind can say, okay, that is this person only, right? Okay, so we have, let's say, W1 weights associated with X1, W2 with X2, W3 is 3, right? So we can assign, let's say, these different values, and it will fire, like if we do the threshold here 5, or we can give the same weight where we have a different threshold like 3, right? So we can see in this case when the threshold is higher, then it will what? It will fire when weather is good and won't fire, right? So only one case it will fire, that when our weather is good, right? Right. So for example, what? So how the value is coming actually, right? So we are getting some values to these each x1, x2, x3, right? So these might be like 0, 1 value, 0, 1 value, and 0, 1 value, right? So when 0, 1 value is coming to it, right? So it is getting two values. One is 0 and another is 1, right? So let's say what would happen if x1, so this is an x1 variable for, right? And this is for x2 variable, which will be also 0 or 1, and this is also 0 or 1, right? So if I am having here this high weight and this threshold, then what you will see how it will fire. So let's say this is 6 and this weight is 0, right? So what it become is 0, it will give me output 0, right? Then I'm going to plus, right? So I hope you remember the summation formula. And then here, let's say it is a 1 and it is also 1. So if it is a 1, 1 into 2, it becomes 2, right? As well as here we have 1 into 2, it also becomes 2, right? So 2 plus 2 makes it 4, right? And our threshold for firing is 5. So what does it mean? Once the weight, once the x1 is off, right, then this neuron will not be fired at all, right? But if I fire this as 6, then automatically you can see whether the others are 0 or 1, it doesn't matter, still it would be fired, right? So you can see how wonderfully, just using some summation and threshold stuff, we are able to we are able to do the prioritizing of the things and able to take the decisions here, right? So in this case, we can see here we have a threshold 3. We are setting our threshold little lower, right? So if let's say W1 and W2 is 0 in this case value, and only W3 is 1, then 2 would be output, which is less than 3. So it will not be 1, right? And similarly with the W2, if is only 1 and these two are 0, so in this case also 2 is less than 3, right? But W1 only these two 0 and W1 is 6 as weight, and if it is higher x1, then here it is crossing the threshold itself directly, so it would be fired. So what we can say, and if we just one more case we can take, if I just forget about it and just take these two, this is I'm taking, let's say 0, and this is as a 1, this is as a 1. In this case 2 plus 2 becomes 4, and then 4 is greater than 3, still our neurons would be fired, right? So you can say just by setting some threshold different values, I can reach to some different decisions, right? Okay, so this way things happen in the neuron system, right? Now let's talk about little bit complex neuron system, which we say multi-layer perceptron, right? And that is going to be like, our brain does not contain only one neuron, right? Till now we were seeing the things from the one neuron point of view, but in reality it contains millions of neurons, right? So it means we have many neurons. Okay, so let's see this thing, and we will divide these neurons into different layers actually, right? So let's see how the neurons would be done with the multi-layer perceptron. Here you can see this is my layer 1, this is my layer 2, and this is layer 3, and this is layer 4, right? And here these are neurons. So just forget about all the layers currently. Like this, let's talk about this one only, right? So this is a one neuron only, right? And these neurons can do everything which we just now we have seen in the last example, right? That is an perceptron, right? Where we were having only one neuron which were getting some input and doing some output, right? So these are actually, sorry, input layer, actually input neurons. So input neurons do what? They take the input from the users, right? So whatever input is coming, some value is coming. Let's say in the last case, this might be representing x1, this might be representing x2, and further they might be representing x3, and it might be representing x4, right? So different neurons, different inputs we have. It takes, so this particular neuron take this input and do some processing. So you can think this is taking only one input, but generating multiple outputs here. You can see 1, 2, and 3. Generating multiple outputs doesn't mean that it generates different output. It just means that as it is connected using the synapses to the other neurons, right, which is in my another layer, right? And this is, we let's say call it hidden layer 1, right? So we call it as a hidden layer. So we will see also why we call it as a hidden layer. So in this layer also we have neurons, right? So this neuron is getting input from this neuron, right? And which is a weighted input actually, right? So it comes some x1 here, and then we have weighted here with the w1. Similarly, some x2 come here, we have weighted it here maybe with something weight w2, right? And you can see here that same input it get from from the input, that is x1, right? It is going to use the synapses and going to pass maybe with a different weight. So it might happen w11 scaling factor for this input for this particular neuron, while for this particular second neuron the weighting factor might be something else, which we might say as w12, right? And for the third neurons the weighting factor might be something, or scaling factor, which we can say as a w13, right? So this way it will do some calculation. This calculation is nothing but the scaling initially here, and pass these values to the neurons, right? So you can see that each neuron of this layer is connected with the each neuron from this layer, right? So each of these input I am getting some weighted way into this each of these second layer neuron, right? Then they do work like a perceptron, right? So this was a completely layer like as we had earlier, that was input layer only, right? And this is our this is another thing, that is basically processing unit as we were doing the perceptron. So you can think this is a one perceptron itself, this is an another perceptron itself, and this is an another perceptron itself, right? So it takes multiple inputs, then it do processing, and then it passes those as an input to the different neurons which is in the next layer, right? And then it do some processing over it and pass it finally to the output layer, right? And then the outputs are being generated here, right? So here might be in the last case, if you are seeing, output might be like this would be one value and this would be 0 if a person is going to the party, and this would be 0 and this would be 1 if a person is not going to the party, let's say, right? So this is the way we have, and why we are calling them as a hidden layer, because in reality what is visible to human beings, so we never see how we are taking a decision in reality, how the neurons are being fired and so on, how the calculation is happening. We are getting some input as our sensory input, right? Our eyes are giving some input, sending, our ears are sending some input, right? So this is this layer, and then we are generating or taking some decision. Then in our mind is coming, oh, this is a person 1 or this is a person 2, right? This is an output that is being coming, right? These are the hidden layers which are hidden from us actually, right? How does this work or do the calculation? We do not know. Oh, sorry. Means we do not know as a human being actually ourselves how we reach to some conclusion, right? Many times we take decision like I am feeling that I should do this thing, right? So why is it happening is you do not know exactly what computation has happened, but neurons has fired to reach to those conclusion, right? So let's see artificial one of the example of this neural network, and this is so this example is going to help us even in understanding why do we have multiple layers, right? So let's see that what these layers are doing, different layers are doing, right? So this is an input layer here we have, right? So when I pass one image here, let's say I'm passing here like a image one, right? So that is being passed as a pixel. So there are pixels into this particular image ones. So those pixels would be passed here as a input to this layer, right? Different pixels. Now this layer will merge these pixels together, different, and do this computation. So here we can see this particular layer is able to find some kind of pattern, right? So it is saying the pattern is this much kind of some kind of boundary. This is taking some another kind of boundary. This particular neuron might be showing some another kind of boundary or pattern, right? So smaller pattern it starts making, right? And using these pattern further, if I take it to further neurons layer, then this layer they are showing here that it is able to create the features, right? So using this, so using one each and every pixel, first of all we were able to generate little bit boundaries and all we can say, and then merging those boundaries or these local features we can say, we are able to find out the face features, right? So face features like eye, so one of them might be showing eye, one of them is basically this particular neuron might be taking care of the nose, and other kind of features are coming, right? And then further when we merge them together, do some more calculation, then we might reach to the faces directly, right? Then we might be saying okay, this particular would be fired if face one, this would be fired if face two, and so on kind of stuff, right? So you can see each layer is doing some computation, right? And from the basic, and they do some computation, and this is a basic computation which is going to work as an input for further computations, right? And slowly you can see on small things we are able to generate little bigger like face features. So neural network was able to find face features first, and at the end it was able to find faces directly, and then it is able to basically uh, even recognize these faces. Okay, so now let's talk about training our neural network. Okay, so if we talk about the most common deep learning algorithm for supervised training of the multi-layer is backpropagation. So what we are saying is backpropagation is one of the training algorithm which is being used to find out the correct weights, right? So the question here is, right? So we discussed here these are basically having some weights coming from here to here, here to here. These have weights, right? So question is here is that how we can know these weights, right? What are the correct weights which we should assign to these, right? So if we are assigning them manually, then automatically there is no self-learning, right? Whole game is of finding the correct weights. If we are able to find correct weights, then the things are done, right? So that is how the learnings happen, right? You find there are few people basically who are quick learner, and there are few people who learns little slower. The only reason behind them, some people are able to find their weights actually in their neural system more faster, right? More quickly. So let's see what is the technique which we are going to see. One of the technique which is mostly used is backpropagation, right? So backpropagation is what way works, that first of all, as we were doing weighted sum of inputs we were doing, and we keep sending it forward through activation function, and then it generates some output, right? And then we look what is the output is being generated. But initially what is the weight? So initially we take weights as a random weights, right? We can take any random weights value, we assign them randomly completely, right? And then with the time what we want to do basically, we want to update these weights, right? So how it is going to be updated actually, as human being learns, that or she basically take one action first and then see. Let's say if you are learning how to play badminton, right? You want to hit a shuttlecock a particular place, right? And you hit it, and then you found, oh, it is going little bit ahead compared to where it should go. Then what does it mean is there is little bit error in my system, right? So then you calculate, oh, that much error is there, then it means I should reduce my heating power by some value, right? So that I can reach to the desired output. So same thing is here is happening. You can think here weight is more like a power here, right? And so that is, they take action, they choose randomly weight initially, and then they see that the shuttlecock is going ahead or it is far behind. Then accordingly it decides whether the weight should be increased or reduced now, right? So after generating output, it start transmitting the output backside. Actually, it propagates that particular difference, right, to the neurons so that it can adjust itself accordingly. So let's see this particular case. Let's say on input 0, we want that output should be generated as a 0. On input 1, output should be generated as a 1. And on input 2, the output should be generated as a 4. So this is what we want our system to learn actually, right? So how do we do this thing? So initially, we will assign some weight to our model. Let's say 3 is the weight we assign to our model, right? So we are just reaching to the conclusion here, not showing exact calculation because the time is less. We have to, but it will clear completely concepts to you. And it is same thing only, which we have seen those formulas, right? So let's say the weight which I am assigning is 3. So what is going to happen here is, let's say this is coming as a output 0, this is coming as a 3, this is coming as a 6, right? So when we see this thing, then what we can find how here is there is an error here, right? So between these two values there is a difference, right? So what is the difference that we call as a error, right? So absolute error we are saying as a positive one actually, right? So is 0, it is has it needs to be 0, it was detected as 0, so error would be 0. It was supposed to be 2, detected as a 3, so there is a difference of 1, so error of 1. Similarly, it was 4, it was supposed to be 4, but our model is detecting it as a 6 with the current weight which is 3, it means error of 2, right? Then we have a square error as well, and square error would be square of these errors. So 0 error square would be 0, 1 square would be 1, 2 square would be 4. Okay, then when we found, okay, this is not generating our output, then let's change the weight actually, right? So we will see how much error is there actually on that particular basis. So cumulative error we might see here, right? And then we can decide that how we should update the weight. And let's say we reach to the conclusion that now the new weight should be 4. Actually little bit we add the weight. You can think that we were unable to hit the shuttlecock at to the particular place by our power, then we increase little bit more power, right? And then we are finding that how much it is going ahead, right? So for now, after putting 4 as a weight, then let's say 0 is coming here, 4 is coming here, 8 is coming here, right? Then we see what is the error here in this case. So error is this and this difference, model correct output and the square model output and the desired output. So model output here is in this case is written here, right? 4. This is a model output and this is a desired output here. So you see the difference between them, and we will take the square, then it becomes square error, right? So 0 0 0 4 2 2 error, and if we take square it becomes 4. 4 8 4 error, if we take square it becomes 16. Right? So now on the basis, on what basis we shall do, error is coming, then whether we should increase the weight or decrease the weight, that is a question, right? So how do we do this thing is basically we try to draw a particular graph, right, which is basically showing what is the relationship between the weight and squared error, right? So what we can see here, that initially if weight, let's say the correct weight needs to be 5, right? So if I am having a smaller weight, let's say 4, then error would be that much. If 3, then error would be that much. If 2, let's say 0, error would be that much. Similarly, it is this side, right? So you can see if we reach the correct weight, we will get our error nearly to 0. But if we are going left or right, then error will start increasing, right? Chances are high that as we go far away from the correct weight, then the error will start increasing, right? So we can start decreasing or increasing weight in the opposite direction accordingly. Okay, now we are going to take a use case, right? And this is a use case of artificial neural network. And what are means, we are going to implement it using artificial neural network only. And how we are going to do this thing, or what is the problem statement, is that whether a bank notes are real or fake, right? This is what we want to determine. So here the notes would given in both ways. So initially training set is given to us, in which it is given that what notes were there. So they have given you some examples of the fake notes and some examples of the real note, and then you need to make the pattern out of this. So we need to make those pattern, find the pattern for the real notes as well as for the fake note using our artificial neural network, right? So there, so basically images came initially, right? So images were huge actually. So data were extracted from images initially, right? So images were of the size like 400 cross 400, right? And it's a huge image size actually, right? So you can think around of 600 pixels, sorry, 16, we can say here, more than around 16,000 pixels we have, right? So if we have that many number of pixels, so that many number of input feature, right? So using all the 16,000 might not be good some places, right? And definitely it would be time taking as well. So one of the ways is basically we extract the correct features. So they have basically extracted the correct features, and the features which they have got is, one is basically they calculated the wavelet transformed image, and for that they were calculating variance. So one of these column is basically showing variance, the another is showing their skewness, another is showing their kurtosis, and another is telling us what is the entropy of image, this one, right? And then finally we have a label. That label is basically deciding whether the node was real or fake, right? So for the fake we have written 0 in our table, and for the real we have written here 1, right? So you guys might be also interested how you can extract these things, but this is not what we can do here. But these are the part of the courses. You can see exactly how you can also extract your features in a proper way, right? So let's see how the implementation is going to happen, right? So first of all, so what are the different steps which we will be going through? So first of all, we are going to read the data set, right? And after the reading the data set, we will define what are our features and labels, right? So defining our features and labels basically. So like here, this extraction work has been done already for us actually, like 400 cross 400 to like for each image has been converted into 4 features, right? So define features means sometimes we need to extract the features out of it. It might happen that out of all 16,000 features, only 30 or 40 features are important. We need to take, and we need to tell the labels as well, right? So here we have these labels. We need to tell to our system what are the labels, right? And we do the pre-processing of our data set. If there is some noises and all those things, those need to be taken care of, right? Then we divide the data set into 2 parts of training and testing. Even though let me tell you one thing, if you would be able to make your neural network properly, then really you doesn't need to worry about pre-processing of your data. If even if there is some noises and all those kind of stuff in your images or your in your data set, neural network has itself a power to extract the correct features automatically, as well as to handle the noises and all. Okay, so let's see here what we are going to do. We are going to divide our data set into 2 parts, right? One we will call as a training, and one we will be calling as a testing. So what this training is going to do, so you can think this thing, let's say if I am teaching you this particular topic, right? So I might be like, we are using this use cases and I'm giving you also solution for it, right? So I'm training you, right? Use case, problem statement, as well as the solution, right? So training, we will be training our neural network first by telling that this is a these are the feature or this is the image and what is going to be its solution. Testing is the phase which is being used for test our model, right? So it is equivalent that after training you, after giving you some examples, I will ask you some question and then I will see whether you can give correct answer or not. So same thing here we have in the neural networks, right? So this is the testing data set which I have taken separately, or these are the questions which I am going to ask my model or neural network once it is being trained to detect whether how accurate it is actually, right? And then we have basically we will have TensorFlow data structure for holding our features. So we are going to use this particular library that is by the Google, that is TensorFlow actually packages, and we will use it to pass our variables as well as labels, and we will then implement the model, right? And this implementation also we will do using TensorFlow only, right? And then after implementing model means initially we will decide how many layers, right? So in the last few slides we saw there were like some number of layers, right? So we will decide how many layers, right? As well as we will decide how many neurons in each layer, right? And after that we will, so once this neural system is decided, then to this neural system we will send our training data set, and then the model would be starting learning, right? Then from the example, the neural system which we will create or which we will implement, it will start learning from, right? And then we will see, so as I showed you just now, that we were calculating the error to do the adjustment of the weights, right? So the same thing here we will do, right? So we will see how much error it is giving. So here we are doing mean squared error. So we take the squared error and we take mean of all the cases, right? So that becomes mean squared error, right? So loss function and all, there are many loss functions are there, and they also play, selection of these also play important roles. So if you want to know more about it, then you have to study these things as well. And basically on the basis of error which our output is giving, the on the basis of differences in the expected output and the output generated by the our model, we will repeat this step and we will adjust the weights actually, and we will try to adjust the weight so that we can decrease the loss. And then it will be doing also the prediction on the test data set, right? So these are the test data set on which we have not trained our model actually, right? So this is the way how we do this thing. So now just let me clear the screen, and now let's go the next slide first of all. Okay, so let's do this thing first of all before we look into the applications. So let's go and do the implementation of it, right? So I am going to work on a Jupyter notebook to do all these things. So let's create a new Python notebook. Okay, so here we have created this new Python notebook. Now first of all we are going to import some packages, right? So there are few important packages which we'll be needing here. Like one would be matplotlib.pyplot as plt. Then we will be needing TensorFlow definitely, and we are importing it as TensorFlow as tf. And then we will be needing import pandas as pd, right? So these are some of the packages which we need to process our data, right? And then we will have from sklearn.preprocessing, we want to import, let's say, label encoder. Encoder, right? Similarly, we will import, if we need to shuffle our data set as well, right? So for that we will import from sklearn.utils, and then we will import shuffle, right? Okay. And similarly we want to divide our data set which will be given to us into training and testing phase, right? So for that we can have from sklearn.model selection, let's import our train test split, right? So we will be using it, and as we will be using it, it would be getting clear to you guys actually. So here we are importing all these libraries. Okay. Okay, so let's do one thing actually, because only half an hour is remaining, right? And the code is little bigger. In understanding it will also take little bit more time actually. Okay, so we will do one thing actually here, that it will take little bit more time. So we will do one thing, that I will open a notebook actually here, so that we can, so this is a data set on which we are going to work actually, that is bank authentication.csv, right? So let me just open, if I have this code with me also somewhere, then so that quickly we can go through the code actually, right? So this is the code that we have actually, right? So we can go through it quickly actually, right? So Otherwise we have only half an hour. So normally during the class sessions we will take you go through the whole code, right? Basically we will be writing each and every line, and then we will be defining what we are doing actually, right? But here as our, and then you can understand even more better way. But still, if you focus now, then you can go through the code and understand each and every step what we are doing here, right? So here the first thing what we are doing here is that we are importing this library, which is matplotlib pyplot, which is basically used to do the plotting, right? At the end we will see how the error has been reduced by training, right? So for that we will use this library. Then TensorFlow library definitely we need to use, right? Because using TensorFlow only we can implement our neural network, right? So for implementing our neural network we need these things, and these are basically for reading our data set and doing some mathematical operation as well, right? And then here we have label encoder, which we will use to encode our label, right? So we want to encode our label, like it might be, let's say, sometime in different kind of values, like a b c d might be there, but our system take only the numeric values, so we might need to do this thing. Or our data might have some more number of classes, and we want to generate one port encoding for them, then we can also use this particular class, right? Or this particular library. And one thing we are going to see is to shuffle our data. So using this shuffle library, we will shuffle our data, right? So this shuffle is going to do what actually is that it will take the data set. So what we are going to do in reality, the whole data set would be given to us, right? The huge data set, let's say we have 1,000 rows that has been given to us, right? So out of these 1,000 rows, we will take, let's say, 700 examples to train our model, right? So in these 700 examples we will be giving, we'll be telling what are my images and what are my solution to it, right? But these 300, I will hide the solution, right? And I will give just these three images to check that how the output can be generated. So this shuffle is doing what? Basically these has a, it might have in a particular way, right? So shuffle will shuffle all those rows. The first row might go to the second at the 10th position and so on. Then we have train test split, that is using this library only we divide our data set actually into two parts. Okay, so let's see. First of all, we will read our data set, and we are creating one function to read the data set. So how do we read it? Within pandas library, we have a function read CSV, right? And this is a file name which where my data set is stored actually, right? That is banknote authentication.csv is the file in which data set is stored, right? So if I show you, this is the that particular same file only. You can see here one variable is variance, another is skewness, next is kurtosis, entropy, and then what would be the output class I want for them, right? So that is available here. Now I need to tell what is the output variable here. So we see these four values, initial four values are my input values, right? And this final one is my output value, right? So this is what we are going to see from 0 till here, it is input, and the next one is the output value, right? So that is what we are telling. So we are extracting from my data frame initial four columns starting from 0 and go till third column. Actually it always go one less than that, right? So we are taking its value and we are storing it into the variable x, right? So you remember from the image what was our x input, right? So I hope you remember the from the images we were having here, that, right? So let me take you to that image so that we can see also what we are setting there, where that image is this one, right? So here this is input x we are providing, right? So we are setting this x, right? And then we are also setting the y value using which is a correct y value, right? The first thing we need to do is to apply one hot encoding of our y value. So by doing this one hot encoding, actually it will convert it into in such a way that for each label we are creating a one particular value, right? So one particular column would be there for each label, right? So if we have two labels, it would be generated two. If we have four labels, it is good that because we want four different classes, right? So we can four different output we can say actually, right? So let's say if if I say if This is op. If the person 1 is an output, then this might be higher, another might be 0. If person 2 is an output, then this another output might be 0, 1, and this might be 0, right? So we need to use this one hot encoding for that particular purpose here, and then we are calling this function. So here these are the functions which we have created, right? So while reading this data set itself, we are doing this one hot encoding call, and now here in reality we are reading our data set, right? And it is storing into x and y, and then we are shuffling these values using the shuffle function, right? And after shuffling, we are dividing them into data set. And when we divide it into two part of data set, one is training set, another is testing set. So we can see here train x. Basically, these are the examples which on which I'm going to train my neural network, and train y. Basically, these are storing the output values for these examples or solution for these examples. Similarly, test x, on which I'm going to test the neural network, right? And this is test y, which is the correct output for these test x, right? So whatever neural network generate output on this test x, we can compare it with the test y here, right? So we can see exactly using train x dot shape that how many variables, how many values are into there, and how many basically columns, right? So here we can see that train x dot shape is basically returning us 1372 columns, sorry, 1372 rows and 4 columns, right? So this is our train x, right? So for the train y, then we can see here, then we have test x as well, right? Then we are going to define the learning rate. So learning rate is something that how much changes you should make in your weight in consecutive iteration. So what you can think is, as we take the example of badminton, right? And when we take the badminton, as I said you, that first time when you hit the shuttlecock and you want it to reach to a particular part of the ground, but it goes ahead of that, right? So then how it was decided that how much it should go on the how much weight you were giving to the power. So how much shift you want to make in your power next in the next trial, right? That is what we are defining using learning rate, right? So smaller the rate, smaller way shifting is happening in your power, right? And if bigger the weight, then the bigger changes would happen in your the power you are applying to your hand for hitting the shot, right? And definitely if it is a smaller rate, then what would happen, it will learn so slowly, right? Our system will learn so slowly because it makes very little change in the weights, right? And if very little changes, then it will take a lot of iteration, right? But if I take bigger weights, then what might happen, that it may tries to learn quickly, but what might happen, sometime we might skipping the correct value. So you can think is this way. Let's say if I say that how much power you change, right? So let's say the correct power that you should apply was 5. Let's say 5 with some its unit, 5 unit of power I should apply to hit that shot at the particular place, right? But let's say I hit it my power 2, all right? 2 unit power I used to hit my shot, right? If the weight is very small, then next time I will hit with the power 2.1, next time I will hit with the power 2.2, and so on, right? And it will take a lot of time actually. And another thing is that you can try to increase the power, and in place of 2 unit, you said basically in a one go I will make a shift of 1 unit itself. So after 2 unit you will have 3 unit directly in the next shot, and in the next shot you will apply 4 unit power, and in the next shot you will apply 5 unit power, right? So this, when you apply your 5 unit power, as you reach there, then you will be knowing, oh, error is 0, then 5 unit is the power which I should keep applying to hitting my shot at this particular pace, right? But let's say if your learning rate even is more higher, then what might happen, that from power 2 which you initially hit, let's say you make changes in your power of 10, then you will jump to 12 directly, right? So you skipped in between 5, right? Then you may jump back actually, then you may jump back here, right? And you might goes into the oscillation actually, right? So there are different approaches actually to find out the best optimal learning rate, right? Which you can see, which we'll be discussing in the courses as well. Then training of epochs. Training of epochs, basically you can think how many time you will hit the shot, right? And adjust your weight, right? That is basically how many time I want to make these epochs go, right? That is 100 we are setting. Then we are setting cost history basically. basically how much cost is there. Cost is basically, you, as we said already, how much differences in there, the desired output and the learned output, right? So what is the error actually? That is our cost of history. We'll be creating cost history for each case, right? And let's say here, let's go ahead after reading our data set. Let's quickly go here and discuss about the hidden layer. So what I decided here is that I am going to have 4 hidden layer, right? So this is one hidden layer. I'm naming, and this is here I'm writing that in the hidden layer 1, I will keep 4 neurons, right? In hidden layer 2, I will keep 4 neurons. In hidden layer 3 also 4. In hidden layer 4 also 4 neurons I will keep, right? So I will be keeping, let's say this model becomes where we have input layer, 4 hidden layers and 1 output layer, right? Then you can see here in each of these hidden layer, we will be having 4 neurons. So let's set this thing now. Okay. So now we need to pass our input, right? So we are passing that input using X, and we are saying it as a TF dot placeholder. So placeholder is basically a way to store the data actually, right? That would be made available specifically during the execution, right? And so within a X we are storing this thing actually, and its value is fixed, you can think as such, and the data type we are setting it as a 32, right? So here you can, we are telling that what kind of input it would be, right? So float 32 it would be, right? And how many dimension is, we have 4 dimension, so it would be having 4 dimension only, right? And here we are not giving any value initially, it is has been set as none. Then later on we will basically import our data set X into this, right? Then we have a weight variable as well, right? So how many weights would be there? So as I told you, each weight is connected to the other weight, right? So here we have number dimensions. So how many dimensions? We have 4 dimensions, right? And finally, how many output we have is 2 output class, right? So from each of those would be coming here to the output class. So we write it as a W. And then we have a B. B is representing what basically? That is our threshold, right? So you guys saw the B, right? Threshold, you guys remember that if it is greater than this threshold, then it will be passing and so on this stuff, right? So those things comes under B, right? There are multiple meanings in different cases, but this is what you can understand currently in a short time, right? Similarly, this is Y underscore, where we will be storing our data, right? The value which is our output value, right? Or expected value, right? This is our real value. Okay. Now we are going to define our model into this multi-layer perceptron function. So we will pass it our input values, we will pass it our weights, and we will pass it our biases. So after, before coming to here, let me just show you here that I am generating here weight matrix, right? So this is H1 weight matrix, that is for hidden layer 1, what would be my weight, right? So that would be, we are generating here H1. So we are defining here what it would be a variable, and the number of values it will be having as n dimension cross n hidden underscore 1, right? So that many dimension it will have, we will have, and that may onto this hidden layer. So how many weights actually, right? So I hope you remember, right? So when we were seeing the PPT, it is in the perceptron. Here we see the perceptron. Yeah. So like here, right? So these were W1, W2, right? And so these are the weights we are defining from X1 to here, X2 to here. So when we discuss about the multi-layer perceptron, right? In this case, what is happening? This unit is getting weight from here, 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 and here, right? So how many total weights are there in between of connection of these? How many units I have here is 4, and how many units I have here is 3. So 4 into 3, right? So 12 different weights here we have in between them. Similarly, here we can find that 3 this, 4, so 12. In this case, 4 is this and 2 is this, so 8 weights are there, right? So same thing here we are telling that H1, that is for hidden one layer, we will be having as many input values we have, and how many hidden layers how many neurons we have in a hidden layer, and then so on. For each layer we are defining our weight using this. And then we have the biases. Basically biases, you can think again, as I told you, that kind of threshold here, right? Even though it means more as well at some places, but let's say it's like a threshold only, right? So biases here I'm defining for each of the neurons, right? So this is saying that for 4 neurons we have in hidden layer 1, so all the 4 neurons biases would be stored into B1, then B2, then B3, then B4, right? And then biases for final output variable. Then we are going to initialize our global variables, right? So initializing global variables means then now the value would be assigned to these variables, right? So these are the variables wherever I have written tf dot variable, tf dot variables. Actually, these I need to generate randomly, right? So as I said, we are generating it randomly, these values, as well as here we have this weight as well, hidden completely the variable, right? So initially all those global variables which we have defined, we are basically initializing it randomly, right? And basically we can save our model if we want to using this thing. So do not worry about this particular statement currently. And so so just forget for a moment, this is just to save our model, right? Sometime I want to save my model, so this model, train model, would be saved. Whatever variables are there, that has been saved, all those things, right? Whatever current weights and all. Now I am going to define my model. And how we will define our model? By calling this function which is multilayer perceptron, in which we are passing x, our input values, then weights, and then finally the biases. So let's see what these values are representing, right? So x, you remember that it is an input value, and weights and biases we have generated here, right, randomly. So when we pass here to our this function, that is x, weight, and biases. So what here we are going to do is, we are first of all in our layer, we are going to add, right? We are writing what operation this layer should do. So we are saying that it should do the matrix multiplication, right? And on which it should do the matrix multiplication, that the input which it is getting. So you remember that was like metric multiplication only, right? You guys remember here that it is getting input from all of these and then multiplying with their weight and then summing up them together, right? So this is operation we are saying here, that at layer 1 do this addition, right? Summation after multiplying the weights and all, right? And as well as putting the biases with them. And after that we were having an activation function, right? So here the activation function which we are using is ReLU activation function, right? And so it's layer 1 output we are using here, and then we are generating the output. So output of it would be in layer 1, right? And this layer 1 output I am going to use within the layer 2, right? Because whatever input we are generating here in this layer, that is going as a input for my layer 2, right? So same thing here we are doing. Actually for layer 2, here you can see layer 1 is an input, right? X was an input for my first layer, but here you can see layer 1 is my input, right? And again we will do the same operation, summation and all those things. That is by add here of operation we are doing, and we have devices b2 for that, and then we generate its output by passing it to a activation function, and activation function which we are using here is the ReLU only, right? And now it is stored in the layer 2. Similarly we will take this its input and put it into the next layer, which is layer 3. Similarly we will put its input to the layer 4, and then layer 4 will generate some output, right? And then layer 4 output, whatever it is generating, then we are passing it to the our output layer, right, which is a final output layer, right? So in this case here we have these two. This is a final output layer where we have these variables, right? So here in this case we are taking output of layer 4 and we are merging it with the weights of our output values, right? So that is being multiplied, and then we are passing for the biases finally, right? And then it generates the output here, and then it returns us the output, right? So this function will return us the out finally, right? So this has been, whole model has been generated, and then you can see in this out layer whole things has been stored, and which we are storing and we are getting here into y actually, right? That model has came here. Okay, now we are defining our cost function, right? So there are different cost functions are there. Few we have discussed already, right? Like we discussed about the function which is like squared error or mean squared error, right? So we have different functions we have here. So that is we are going to do here is to reduce to mean. We will take the mean only, right, by applying this cross entropy with logics, right? So this particular thing we will apply, right? This particular function for calculating the cost we are applying. And what you can see here, what I am passing is the real value, the one which is being detected by my model, right, or generated by my model, right? So you remember what was generating by my model is y. I'm storing into this y whatever is being generated, right? That is a generated output. And I hope so you remember earlier we have stored into this y underscore the real output, which is the correct output. So it is basically calculating the mean loss for it, right? And after this we are basically going to tell what is going to be our learning rate which we generated, right? So this is an one particular gradient descent optimizer, which is basically our learning algorithm, right? Which is basically like back propagation we talked about, right? So which basically using which we learn some weight, right? So here we are passing it learning rate, and we are minimizing the cost function here, right, by passing the cost function into it. Okay, so because we want to do what, basically in reality we want to minimize the cost function or the error. So this is going to learn the weights accordingly so that error can be reduced. Okay, now so I have set up here, but the execution has not started yet. Model has been set up, everything set up, but execution will start only when the session would be created in the TensorFlow. So how do we create the session in a TensorFlow? By calling this function tf.session, right? And now session has been created. Now I am saying kindly execute the code, right? And that is basically run init is being used, right? And while doing this thing, so how much I should execute it, that we are going to tell it using the epoch, right? So how many times I want to execute it, how many time I want my system to learn from the examples, that is basically 100 we defined. So number of epochs is 100. So it would be learning, it would be you can think that in a badminton case it would be hitting 100 shots, and within 100 shots it will try to learn the best power it should put to put the shot at the right place, right? And here we will store MSc history. So as in each epoch, right, as in each learning, what was the error, right? So that we will be storing into the MSc history, and how much accurate our result was, that we will be storing in the accuracy store actually, right? So now we are doing this in session.run, right? So when we write here session.run, we only call here init. Init is what, basically for initializing my variable. So I was saying kindly initialize it. Here I was saying defining this initializer, that randomly it would be initialized. But when I say session.run init, in reality now the values are initialized, right? And now what I'm saying is session.run. So I'm saying kindly run my code, right? And what I'm passing here, training step, right? So training step I'm passing here, what are my training steps? Then I'm feeding here dictionary. So this is a feed dictionary basically, using which we tell what is my input values and what is my cost for each epoch, right? So first time it is learning, so I write 1 here, so it is learning first time now. Then it generates some cost, and that cost I will be appending in this you can see numpy array here, and basically in the earlier numpy cost we will be adding this cost here, right? So that we can keep track how the cost changes from one iteration to another iteration, or one shot like I played, then how much error, then second shot when I played, how much error, right? So we can keep track exactly how much error we are reducing or increasing, right? Then we are doing the prediction, right? So that is prediction for the correct prediction which we want to do here. So we are looking how many correct predictions are there, right? That is how many values that has been generated are correct. So we are saying here y we are passing here, and y underscore we are passing here. So it is matching both, and as many equal values are coming, that is coming here, right? Then it is calculating the accuracy, right? And after that we are going to run now our model, right? And for running our model we need to run the y here, right? So as we run the y, and we tell it that this model should be executed. So here first we did here, when we were doing this feed initial run, we were doing training first time, right? Then we were check, sorry, this here session.run, right? First time we will do training, and at the same time here I am looking how much, what result it can generate on my testing set, right? And this way we are producing it. And then we can see here that MSc basically for calculating mean squared error, we use this function tf.reduce mean and squared. Basically this is how we are calculating the error, that is the correct value is in my y variable, and predicted value in my test underscore y, right? And we calculate error this way. Similarly, we will run this code, and after that we will in the history we will add this mean square error which we are getting, right? So that way accuracy history and mean square error we will create, right? And then we can plot also accuracy graph. So accuracy graph is basically our all the accuracies from step 1 to step 100 is stored in the accuracy history list, right? So I can draw this using these lines of code. Plot function directly do the plotting for us. That is enough for us actually. Now if I want to give some name to x-axis, I'm giving here, to the y-axis I'm giving name here, right? And I'm generating my final prediction. At the last, after doing all the training testing, I'm generating my final prediction. Then again, we need to find out that test final accuracy, right? And that is being said here. For this final test accuracy is coming whatever here, we will print it. Okay. So I know I go through this code little quickly way, but if I would be typed, so you can see here what is the output of it. So here it is writing that in playing the first shot, whatever random weight it generated we are not looking into, but cost was 92 or 0.92 actually, right? And mean squared error was around 1.5, right? And if we see the training accuracy, it was 0.44, right? So we were training our model and we were looking on to those training data set itself, that what accuracy it was generating. We were testing itself on the training set only, right? So it generated this 44% accuracy initially, right? Then we changes some weights. Then we look how much changes here. We can see no, not much changes. Then change more, not much changes, change more. So as we change more in the fifth step, you can see accuracy got changed, right? Training accuracy got changed actually. Then we keep doing this thing. Then you can see cost is also reducing, mean square error is also reducing, and accuracy is increasing and reached to 65 percentage itself in the 8th epoch, right? So this way we can go through all. It is printing us the result how the things got executed, and at the end, as we have given the command to draw this graph, it is drawing, and also it is saying that at the end the training accuracy reached to 96.9 actually, right? And when we draw this graph, basically how the accuracy was changing with respect to epoch, you can see it is representing the epoch, and it is changing from here this way, right? So initially this, then it is this. So if you remember, for like 6-7 steps accuracy was not changing, and suddenly it changes a lot, right? Then it starts changing, right? So this way it keeps changing here, and it reaches here. This is where we have reached, right? In 100 epochs, so which is like little lesser compared to 100 percentage, right? And if we see accuracy on the test data set, this is a data set on which we have not trained. This is around 94.54 percentage, right? So this is way we can do this. So it happens actually that a lot of Python stuff like TensorFlow we go little quickly, right? So that is not a problem, right? During the course you will be going through first making the base properly and understanding all these things, what these particular function do and what is this and what is this and on so on, right? So no need to worry, but I hope you understood exactly how easily by writing few lines of code we can make our classifier which can detect, right? Which can detect with the accuracy of 94.5% whether a particular node is fake or it's a real node, right? So you can see how powerful a neural network is. Okay, and let's see here now. So let's talk about some of the applications that is being used. So neural network is used in medicines nowadays as well. So that is modeling and diagnosing the cardiovascular system, right? And so there are a lot of lot of diseases are there, right? And neural network can be nowadays, you might, I don't know you know all this or not, nowadays even work is happening actually, which by interacting with human being they can detect even proper medicines, right? Not only this thing, even generating a new formulas of medicines, right? The work is going on into this area very nicely. And as I told you already few example, I think, I hope so, that is that skills it is getting using neural network, like we as a human being many times, like we can do sketching, right? We can create music, we can do painting, right? Now the systems has been created in such a way which can do painting, and these skills can also be learned, right? So in medicines it is being used, in business it is being used a lot, right? So you might be, if you have done shopping with the online stores, you might be seeing some recommendations it is giving to you, right? So those recommendation, how it is coming, the bad, most of the great recommendations come through neural networks only, right? And you can see how nicely they are recommending it, right? So you might be seeing it whenever if you, let's say recently I bought a tablet of Samsung. So when I bought the tablet of Samsung, it was able to recommend me exactly the right cover that I should use with my that particular with that my particular tablet, right? So you can see how nicely it can learn, right? So one way is that some patterns is there. Sometimes it can extract all those things directly from the text as well. So anyways, so I hope so all these things are clear to you guys, right? And let's go through it what we have learned today. Basically we learned today why neural network is needed and what is neural network. We started seeing the building block of a neural network, which is one perceptron, and itself a one perceptron is a very powerful unit which we have seen. And then by merging together many these simple perceptron unit, we can make multi-layer perceptron which is ready to solve the problems like human being, right? And then we see how the weights is basically how we adjust the weight with the iteration by looking into the errors, right? So we calculate the error and then see how much weight we should adjust. And at the end, we talked about the use case implementation, right? We did the implementation of a particular algorithm, right? So I hope so it is clear to all of you guys, right? And you got very well way now it has been generated, that it has been generated in your mind that what things you can do, and you got initial exposure to the neural network, and you can see how easily you would be able to create a classify using neural system, right? So if you take 1 or 2 hours, you will be understanding TensorFlow also in few hours, and then you are damn ready for solving lots of interesting problem in the industry as well as social problems. Okay, so let me know if any queries you guys have. Anyone has any query, let me know. Okay, none of you is clear. Thank you. Yeah, welcome. Yes. Yeah, Ashutosh saying thank you, sir, for such a great session. Yeah, welcome, Ashutosh. Okay, as I told you already, if you guys are interested in attending more free webinar from Edureka, very great things. Cool webinars are coming here. Deep learning, some decision tree, which is starting in few minutes. Blockchain also, and a lot of other kinds of webinars are there, right? So you can just go to this particular link and click on join this group. And as you join this group, you would be able to access 150 webinars in free of cost every month, right? In a month. So that's a huge opportunity you have, right? Okay, thank you very much, guys, for listening with so much patience. And then you can ask your question also. Like there are a lot of people here I know is are listening this thing on via YouTube. Live YouTube is going on. So you can. So if you want to be the part and want to ask the live questions, you can just join this group, right? So after that, you would be even able to ask the live questions. So Ravi is asking, Edureka web page also can you show us? Yeah, sure, we can see this page. So we have edureka.co, right? So if we see, this is our Edureka page, right? And you can also look for the courses. Like there are a lot of training courses are there, right? From like you can do whole post graduation as well, or you might be interested in one like say only like Python certification course, or maybe some TensorFlow system. Like I showed you, you can search here. Like let's say TensorFlow, I am interested in. Then I click here AI and deep learning with TensorFlow. A program is there. Like here, you can go through different programs available here, right? So this way you guys can go through the website as well. Okay. Anything else? Anyone else? Any question? Okay, Santosh saying thank you. Yeah, thank you very much. Okay, yeah, thank you very much, guys, for listening with so much patience. And I hope that your journey towards the coming technology, that is neural network, which is going to solve a lot of problem, would be solved, right? And please, the people who are watching this session here, please fill the feedback from. Thank you very much. It's really necessary that you guys fill that feedback form. Okay, guys, bye bye, take care, and all the best for your journey, life journey.